Yes, welcome to Vision Plus and welcome to this Senior 4 Mathematics. We have started the Senior 4 Mathematics with Unit 1, and the first topic is complex numbers. And to start with, we are saying that a complex number is a number represented by an expression that is in the form of a plus bi, where a and b are real numbers and I is a symbol with a property that I squared equals to -1. This is a key concept. This is a key property in complex numbers. It is the one that assists us to find the square root of a negative number. So we are saying that any expression that is in the form of ab plus I is a complex number. And if you square both sides here, you take the square root, take the square root on both sides, you find that I equals to the square root of -1. And this property was introduced by a Swiss mathematician called Euler. Traditionally, they used W and Z to denote or to stand for complex numbers. So we are saying that any complex number Z is in the form of A plus BI. And you find that in some books that they're using, the complex number Z is given by X plus YI. It is very rare to use W, but whenever you see W, you know that that is the same as, that is the symbol that denotes a complex number. So, and we are saying that this part, which does not contain I, is the real part of complex number Z. In this case, is A. And the imaginary part of the complex number Z is B. Both A and B are real numbers, but B is it contains the imaginary part of the complex number. That means we are not in position to get the square root of a negative number. So this property comes in to substitute and enables us to find the square root of a negative number. So there are two parts here. One is the real part. This one stands for real part. And then in this one stands for the imaginary part of the complex number Z. For instance, if I just say, let me just put a quick example here. If I say the complex number Z equals to 4 minus 3i. Now, what is the real part and what is the imaginary part? The real part of this complex number Z is the part that does not contain I, which is 4. Always take the number and its coefficient. And the coefficient is the sign before that number. The coefficient of that number is its sign. Take it with its sign. That is positive 4. And then for the imaginary part of Z, it is the number attached to I, but you take the sign before that number. The sign before this number is negative, and the number is 3. Both 4 and -3 are real numbers, but we are saying this one is the imaginary part. It is trapped in the imaginary part. Both the real and the imaginary parts can be negative or positive. It is not a must that the imaginary is always negative or always positive. It depends. So they can be negative or positive. So this is the brief introduction to it. But you keep in mind this property is very, very vital, very important. And let's see how we can apply that property in assisting us to solve example 1. And example 1 says, solve the following questions. And the solution here we shall say, for part A, it is x squared plus 9 equals to 0. The solution to this equation is actually, what are the values of x? or what is the value of x for which this function will be 0. So simply we shall just try to make x the subject of the formula. So here we shall have x squared. Now we need to take 9 that side. If we take it that side, it becomes a negative. 0 minus 9 is a negative 9. But we are looking for x. That means there is need for us to take the square root of x so that we apply the square root on both sides. We are making x the subject. So the square and the root will cancel, so that here we shall have that x equals to negative root of 9 is not a real number. Negative the square root of negative 9 is, this one is not real. There is no real root for that. It does not have real roots. So what shall we do? We shall just try find ways of introducing this I on negative 1. So to make your solution easier, you can easily see that negative 9 is the same as 9 times negative 1. You can simply see that 9 times negative 1 is negative 9. So we have not made any change to the equation. But what is negative 1? But we have said that negative 1 is the same as I squared from the Euler's property, which says I squared equals to negative 1. So we shall substitute here for it. So we shall have here root of 9 I squared, where I squared is denoting the negative 1. But we know that if you have two numbers under the square root, if you have two terms under the square root, which are products, which are being multiplied, because 9I squared is the same as 9 times I squared. So it is the same as taking the square roots of those terms independently. So, and we know that if you are taking the square root of any number, it is plus or minus. Why? Simply because if you square its positive or its negative, it gives you back that same number magnitude as positive. And what is the square root of 9? It is 3. What is the square root of I squared? I squared. It is I. Because the square and the root are going to cancel. Simply because the square root means half power. This is the same as. So it is the same as I. So the solution to part A is that x is plus or minus 3i. So these are the roots of that equation. These are the values. If we substitute for them here, the function is 0, or the equation is simply 0. So here we just say now, therefore, x has two roots 3i, or x equals negative 3i. That is for part A.